So, oh, I guess the only good news is that you're only going to get one question on find the centre of mass, right? Because they're so blinking long. So be really, really careful, right? Double check you're working, because, you know, WebAssign just knows, you know, the answer's 14. And if you say 44, I don't know what you did wrong. So what's the new guy in town? We're going to look at what is the surface area problem. And we're talking 3D here, not two-dimensional calc surface area. So imagine you've got a region on the floor, D. If you project that region up until the surface Z equals f of xy, can you see that when it reaches the top, it would look like this kind of curved rectangle? Now, when you normally get a double integral, aren't you getting the volume of this shape from bottom to top? That's what a double integral of d f of x, y, dA would get you. To find the surface area, it's a double integral over d of this weird guy, which is the partial derivative of x squared plus the partial derivative of y squared plus 1 dA. So this is your memorize me, write me down, whatever. I would memorize just because it's less work, and use him. So when you're being asked to find the surface area of a shape, you're going to find this double integral. And that means you're going to get lots more practice at finding double integrals. And the usual rules will apply. Don't you have to find the limit of integration of d the usual way? That's not going to change. And if the function has bits of circles in it, won't you probably use polar when that happens? So pretty similar to what we've done in the past. Now, let me show you visually, because they draw much better pictures than I do, what that looks like in a homework example. All right. Are you looking at question 1 right now? Can you see z equals 12 plus x plus y squared? Is that what you see? Okay, good. And maybe make it a little touch bigger. Right. We have to find this surface area, right? This little guy here. And the function that we have is a z equals. So I'm writing this down right now. So z equals 12 plus x plus y squared. That is essentially your f of xy. And the region D, can you see it down here on the floor, is a triangle. Now I'm going to write down that triangle and I'm going to orientate it differently, because the x goes this way is positive, and when the y goes that way, it's negative. And it's quite hard to kind of figure out what D looks like in the way that it needs to be kind of looked at. This is what I'm writing in right now. Well, hello everyone. What we have here is question 1. I'm going to set it up to this point, talk you through it. At this point here, I think it's doable. So this is our orientation. And if you look at the question, it tells you it goes through the origin, crosses the y-axis at -2, and this point here. And that's the line. So this triangle is representing D. And if you notice, I've decided to orientate it as a type 2 horizontal. So the y values go from 0 to -2. And the x values, that's big, right? It's further to the right. And that's small. So it goes from 0 to the equation of this line, which is y equals -x. But in the format that I need it to be, it's rearranged as x equals -y. And here we have our function that we're going to be dealing with. So that's the setup. The region, our triangle, our z. Now if we move on, the next line essentially is setting up the integral from the limits of integration of this square root. We then find that derivative is 1 and square it. Find this guy's derivative and it's 2y and square it and add 1. And then you make it look pretty, you get that guy. So if we now move over to here, If you integrate this with respect to x, you essentially just add an x here. You then evaluate to x equals negative y, and then you evaluate it to x equals 0. And when you do that, you essentially, you get that. And at this point, I think I can stop, because the u sub 4y squared plus 2 will take you to the end. And if you do it correctly, your final result will be 13 root 2 over 3. And that's what they tell me. So hopefully that is that helps fix question 1. And we are done. And the function that we're going to be dealing with is this guy. And the region D is everybody inside there. So I've basically got a circle radius 2. And so I'm going to do polar. Actually, this makes my life so much easier, isn't it? Easier to do when everybody's a number. So that's my region D. They say everybody inside that circle. Okay. So the surface area, you have to rearrange this formula to become Z equals. So what am I going to do? I'm going to say 2Z is 8, take away 2x, take away 4y. So 1Z is 4, take away an x, take away 2y. Are you all comfortable about rearranging this one to be more in the format Z equals? So it's going to be a double integral from theta equals 0 to 2 pi, from r equals 0 to 2, the square root of, and then remember to put your r in, dr d theta, and the derivative of this with respect to x is -1, then you square it. The derivative of this with respect to y is -2, and then you square it, plus 1. So we are looking at theta equals 0 to theta equals 2 pi. 1 plus 4 plus 1, so that's the square root of 6 r. Oh, variable separable. You agree? Variable separable. Everybody in the limit of integration is a number, and that just has r's in it. So I am going to go theta equals 0 to theta equals 2 pi, and just because I want to, I'm going to give that guy the square root of 6. And then I'm going to do r equals 0 to r equals 2 of r. If you do that guy, you get 2 pi root 6. And that guy is a half r squared, which gets you a half times 2 squared, which gets a half times 4, which is 2. So you end up with 4 pi root 6. And am I good? That is actually the right answer. So number 1's a kind of weird anomaly, which is bugging the heck out of me because I'm still thinking about it. I suspect I've probably looked at the picture wrongly, and the way Maggie was looking, it was a plus going up the way, and I just orientated it wrong. But anyway, that's that guy. Much cleaner, agreed? What can I say about that? Are we comfortable the minute you see a circle, you think polar? Right? If D is circular, half a circle, whole circle, think polar. Now, this one has 5x plus 3y plus z equals 15. And we're being asked to find the surface area of this plane in the first octant. Okay, here goes. This is the usual way in which we draw on 2D paper the 3D axes. What we don't typically do is add in too many more lines. But if I add or extend these lines, can you see that the 3D space is actually built from 8 separate regions called octants? Can you remember in trig, you had 4 quadrants, quad for 4, right? Can you imagine that 3D space is broken into 8 octants? And the first octant is almost always the one that we deal with. And the first octant is where my finger is circling. Isn't that the place where everybody is positive? And that's guaranteed. Now, if you want to know how they name the others, that guy's 1, this guy's 2, that guy's 3, that guy's 4. Then you go downstairs. That one's 5, that one's 6, that one's 7, and that one's 8. I'm not even going to attempt to draw it. It's too messy to even think of it. But you can imagine the top 4 and then the bottom 4, right? The ones above the XY plane, 1, 2, 3, 4, kind of going anti-clockwise. And then below the floor, guy underneath is 5, 5, 6, 7, 8. These are the octants. Now we know it's in the first octant, which is good. So I'm now going to redraw only the piece of the shape that we're really interested in. Is that? And then it looks like you haven't given me enough information. I don't know what I'm trying to find the surface area of. So here goes. I am going to draw a quick sketch of what that plane looks like inside the first quadrant. And the way I'm going to do it is find out where it cuts the X, the Y, and the Z axis. So here goes. If you want to know where it cuts the X axis, that happens when Y is 0 and Z is 0. Does that make sense? That it crosses the X axis when the other 2 guys are 0. So if you look at this guy, it's basically 5x equals 15. So that means X equals 3. So I'm going to put a 3 there. Now, if you want to know where it crosses the Y axis, can you see Y is 5? So I'm going to put a 5 here. And if you want to know where it crosses the Z axis, don't you make X and Y 0, and you get Z is 15. And then if you join these guys up, can you see one of those funny little 4-sided dice shapes that you very often get? Now, the surface area that they want us to get is this triangular piece here. Are you with me so far? I want to find the area of this triangular piece. So I now need to know, and I'm just drawing another picture here. I need to know who D is. And D is that triangle on the floor. Can you imagine the floor triangle going up and making that other guy? So this is D. Right, so I should have all the pieces that I need. I'm going to try and be careful, although I wasn't last time, in orientation. Well, I know it's the origin, so that's easy. This guy is the x-axis at 3, and this is the y-axis at 5. So there is a better picture of what D looks like. You still with me, guys? Right. Let's write down the limits of integration and a little bit of adjusting to that, and we should be good to go. Right. So I'm still going to go for vertical because it's my go-to guy. X is going to go from 0 to 3. Y is going to go from 0 to that guy, right? And isn't that guy whatever the equation of this line is? We've done quite a few triangles, so this hopefully gets a little bit easier. What's the slope of this line? Just using rise over run. What is the slope of this line?
-5/3.
Agreed. So won't the equation be, at least to start with, -5/3 x? Now, in this question, and quite a lot of these, don't you also know the y-intercept, which is 5? So are you comfortable with how I got the equation of that line? Rise over run get me the slope, and it crosses the y-axis at 5. So this guy here becomes -5/3 x add 5. So the area of the surface is going to be the integral from x equals 0 to x equals 3, the integral of y equals 0 to y equals -5/3 x add 5. Now I have to do a little bit of adjustment here. I know that's the format that they gave us, but don't we have to rewrite it as z equals? Because I need to know this guy. This is essentially who f of xy is, right? Z equals. So square root of, if you differentiate this fella here with respect to x, you get -5 and then you square it. With respect to y, you get -3 and you square it, plus 1. Nine, 10, 25, square root of 45. If you integrate the square root of 45 with respect to y, you're basically just integrating a square root. So you'll get square root of 45, oops, double bracket, y. And then you're going to evaluate it at 0 and at that guy.
Sorry, you said 45? Is it
Yes.
35?
Oh God, don't tell me I can't count. Yes, it is 35. I'm suffering lack of sleep, guys. I can't count to save myself. But the fact that you can is good. You keep me in. But so it's going to be this guy times -5/3 x add 5, take away a whole load of nothings. And I would probably pull that out. And I'm going to dot that. Would you agree that's just a pretty standard calc 2 integral with some ugly fractions going on? And allegedly, the answer ends up being 15√35/2, which kind of matches that. So I'm comfortable I'm probably in the right tracks. Any questions so far? We're comfortable with the 2 good ones that we've done. Where shall I go with the next one? Jump to 5. We are being asked to find the area of the surface that is part of a cylinder called x² plus z² equals 16. And essentially, they're telling you what the d is by giving you the coordinates of the triangle. Do they go back to 0 again? Yeah. 0, 0, 2, 0, 0, 2, and then 2, 2. So it's not actually a triangle, it's a rectangle or it's a square. But before I even do the D region, which actually isn't too difficult, let's take care of this guy right off the bat. Would you agree that that's a very disguised Z? And we need it to be written that way. Even if it started life off that way, for our formula to work, we need that, because essentially that's a f of xy. Even though it doesn't have y's in it, it's still a f of xy. Now, if I draw a little picture, let's find out what kind of shape this is. 0, 0, 2, 0, 0, 2, and 2, 2. Okay. Oh, that is such a simple shape, I'm amazed. As you get, it's just, what, a square? Okay. So I'm not too worried about the limits of integration. They're not really a problem. It's probably going to be integrating that's going to be the pain in the butt. So here goes. It's going to be the integral. Oh, darn it in space. I'll write down what my problem is. Should I do x first or should I do y first? That's my problem. I know which way I'm going. Any idea which way I'm going to go? Am I going to do x first or y first?
Possibly y?
Correct. And the reason I'm going to go y first is I think if I go y first, I might. Nah, I changed my mind. I'm thinking I might be able to get a better integral. And now I'm thinking about it a little bit deeper. Do you know, it doesn't matter. They're both ugly, no matter which order I do it. So y first, if you like, but I'm going to do x just because I'm being awkward. I was hoping that maybe I could get a u sub out of this thing, right? But I can't. And so I'm just going to set it up as the integral from y equals 0 to y equals 2 of 1. And the integral from x equals 0 to x equals 2 of some really ugly guy that looks like that. And evidently, that guy is easy. I can do that in my head. You may or may not know this guy. And he is, because you go and you look at the back of the book, that guy's integral is this fella. The integral of the square root of 16 minus x squared evidently is 4 inverse sines of x over 4. Now, if you go and look at the back of the book, they will tell you something like this. That the integral of that guy, right, is a inverse sine of x over a. Can you trust me on that? Evidently, even they don't always come up with nice questions, right? You know, U sub questions. Or Maggie, you're looking puzzled.
Yeah, I'm a little bit confused. Why did we leave f of x as f of x when we took the integral instead of doing the root thing?
Oh God, yes. I should go to bed. I need sleep. That is the answer to what you would get if you were going to find just the area. But we are going to get very similar answer. Let's differentiate this guy with respect to x, right? If you differentiate, right, because the question is that guy squared plus 1, right? Okay. Now let's put Maggie's information. If you differentiate this guy, you will get 1/2 16 minus x squared to negative 1/2 times negative 2x. Are you happy about what that derivative looks like? This guy. Then you stick it in some brackets and you square it. So that guy, square. That guy is nothing, and that guy is 1. So you're now going to have the integral from 0 to 2, the integral from 0 to 2 of if you take this entire mess and you multiply it together, you get negative x, which becomes x squared, and this guy, which becomes 16 take away x squared to the negative 1 plus 1. Which now makes which now means we have got that guy. X squared over this fella plus 1. I wish I'd stuck to my mistake, because my mistake's actually going to look almost like the question. I'm going to call that guy 16 minus x squared over 16 minus x squared. That means I can do this guy plus 16 minus x squared all over 16 minus x squared.
Professor Robertson, isn't
Yes.
the 16 minus x squared a square root on the bottom?
It would have been originally, but then I squared it. And so it's now that, and so it is a pure -1, but it is worth mentioning based on past experience. Right, now this guy becomes 16 over the square root of 16 minus x squared, dx, dy. They cancel out and you get 16, and that's not a square root yet. It will be in a minute. That becomes 4 over 16 take away x squared dx dy. And that's the guy that's the inverse sine fella. So you find the integral of this guy, and you will get 4 inverse sine of x over 4 out of it, evaluated at x equals 0, x equals 2. So that guy is the inverse sine fella. And then once you get that answer, you just integrate from 0 to 2. Actually, you can separate them now. And after all that horrible work, it ends up being 4/3. Oh God in Himmel, that was horrible. We need an easy one to finish with, don't we? So, keep the last few pages around. Some of these you're going to do from scratch and just take your time. That was too quick for anyone's good. So a nice easy one to finish today with. There are only actually 7 questions, and now I think you know why they take so long. There is my surface, and D is one of those between 2 circles. D is between that circle and it's between that circle. So if I draw it, there's a circle of radius 3, and then there's another circle of radius 2, and our guy is between it. Do you see polar coordinates as a good system? So D is going to be radius from 2 to 3. And since it's the whole, make sure it's the whole thing and not in any quadrant, it's the whole thing, it's going to be from 0 to 2 pi. So that makes life easy. Z is already set up, that makes life easy. And so the area of the surface will be the integral from theta equals 0 to 2 pi, the integral from r equals 2 to r equals 3. Then we do that square root thing and then do a dr d theta. And it's going to be the partial derivative with x squared, partial derivative with y squared plus 1. If you differentiate this guy with respect to x, at least you get negative 2x and then you square it. You do it with y, you get 2y and then you square it and then you add 1. That guy gets you 4x squared. The one next to it gets you positive 4y squared plus 1. Since I'm in polar, don't I have to convert 4x squared plus 4y squared plus 1 into something using r's and thetas, typically? That is not as bad as it seems. What does 4x squared plus 4y squared get you if you turn it polar?
4r squared.
So this will just be 4r squared plus 1. Would you agree that the variable's separable? So I'm going to do from theta equals 0 to theta equals 2 pi of 1. And then I'm going to do r equals 2 to r equals 3. And then I'm going to bug Mia, because she's my go-to person when this happens. Mia, what method are you going to use to integrate this guy?
U sub.
U sub, right? I think if nothing else, won't we just know how to do, we'll be really good at U subs, right? By the time you finish this 10-week course, you can do U subs standing on your head, right? I'm not going to finish that. We're getting kind of close to the end. But wouldn't this guy be 2 pi eventually? Oh, does anybody know how I can just look at an integral of 1 or an integral of 2 and know what the answer is in my head? Because you know I'm not very careful, but I tend to get those right. Can you see the shortcut of why I know that's 2 pi?
It would be just theta and then, yeah.
Oh yeah, you could do it by integrals. I abbreviate it. If it's
you
a
can-
number, isn't the difference times the number of your answer? So this is 2
Oh,
pi. So if somebody went and said to me, x equals 7 to x equals 9 of 3, right? I would just say 7 take away 9, that's 2, 2 lots of 3. I could tell you the answer is 6. So if you're integrating constants, right, 1s, 2s, 3s, between two numbers, just find the difference and multiply it by the constant, and you've got the answer. Okay, it might save you 10 seconds, but you know, it's better than nothing, right? And that one is horrible. Well, not horrible, but long. And I think it's a good point for us to finish. And I've got a little note to myself that as soon as you lot go, I'm going to have the solution to number 1 done. And I'm going to figure out why my orientation is so back to front. And I'll put it in class resources, right? So it'll be in the second module when you go looking for it. And I'll probably say something like question 1. Right, last names and bye-bye. I'll see you tomorrow.
Mr. Robertson, can you
Yes.
say again what the standard integral was for that turned out to be something inverse sine?
This thing here? Yes. That one? Oh, you can't see that one. Okay. Here we go. That guy there is 1 over a, the inverse sine of x over a. Or, now I'm thinking about it, it's definitely inverse sine of x over a. I'm not 100% sure if it's 1 over a or a. Now, do you know what I'm talking about when I say at the back of the book there's a whole list of integrals? So if you've got time, go and have a look, and it's that one or it's this one. My
Okay.
gut feeling is it's this one.
Okay. Thank you. Have a good day.
Okay. Right, hi everyone. This is my second attempt at question 1, and I did get the orientation wrong. So my apologies one more time to Maggie. She had it nailed. Actually, the y value was down at -2, but the x value was actually at +2. So the triangle that we should have been doing is that one. That's D. And now that I've got that guy sorted out, we can work now on essentially doing the integral. And I'm going to do my vertical one again. So I'm going to do x's, going to go from 0 to 2. And the y values, well, the y values are going to go from 0 is the big guy, to here. And this straight line has the equation. Oh, sure. Let's do that again. Hello, everyone. This is, I think this is my third attempt at doing this. I almost got it right. And then in the setup, but I screwed up. So this is the surface area question, part A. And we're looking at question 1. And my orientation was wrong. And it passes through the origin. And it passes the y-axis at -2. And it has a is it 2, 0? X goes to 2, -2. And that's here. So when you join those guys together, there is our D. And when we look at that, this region here is our D. We can imagine the equation of the straight line, which is y equals -x. So I'm going to do it using the vertical ones. And this point here happens to be 2. So x is going to go from 0 to 2. And y is going to go from -2 to the straight line. And that there are the limits of integration for D. Now the function that we're going to be doing it with is this guy. And the area of the surface then is going to be, let's get all these distracting pages out of the way, the integral from x equals 0 to x equals 2, the integral from y equals -2 to that guy. So -2 is the small one. Right. Everyone, let's try and find the surface area. Right. On our original picture, we are going to find that this triangle crosses the y-axis at -2, and that it passes through the point -2, 2. So we go here, passes through the origin, and where's the other one? And it goes through that point there at 2, -2. So our triangle looks like that. And I am going to not do it vertically. I'm going to do it horizontally. And that's region D here. So because I'm doing it horizontally, the y values are going to go from 0 to -2. And the x values are going to go from here to here. On this side, we have a line, and the line is y equals -x. But if you rearrange that, it's the same thing as x equals -y. And so we are going to go from there to there. So we are talking 0 to -y. And there is D. So my surface area is going to be the integral from y goes from -2 to y goes 0, and from x equals 0 to x equals -y. And then it's going to be the square root of the partial derivative with respect to x plus the partial derivative with respect to y plus 1, in this case, dx dy. Square root finishes there. And the surface z in this question happens to be 12 plus x plus y squared. So our surface area is the integral from -2 to y equals 0. Integral from x equals 0 to x equals -y. If you differentiate this with respect to x, you get 1. With respect to y, you get 2y squared, and then 1. So we now have the integral from those values of y of 4y squared plus 1 dx dy. This comes out a lot nicer. So it's going to be the integral from -2 to 0 of, well, let's just integrate. If you integrate this with respect to x, you get x, that guy. Evaluated at x equals -y to x equals 0 dy. What do you get? Well, you get negative. Okay. Plug in 0, plug in -y. Plug in 0, you get nothing. So I guess you're going to just get -y, the square root of 4y squared plus 1 dy. And at this point, I should be able to figure out where we're going next. I should be able to just plug in a u sub. And the u sub would be 4y squared plus 1. So that's du by dx equals 8y. So du is 8y dx, and divide both sides to isolate the dx. And so we have got the integral of what? We have -y square root of u times 1 over 8y du. And that's going to be -1/8 square root of u, which in turn is going to be 4y squared plus 1. Which I should just be able to evaluate at -2 and at 0. Let's see what we get here. If you plug in 0, you get -1/8 square root of 1. Take away -1/8, the square root of 2 times 2 is 4, 4 fours is 16, so I guess it's that guy. And so that's -1/8 pi plus 1/8 square root of 17. And that gets me 1/8 square root of 17 to take away pi. What? What you want? No, be good.